Hey everyone, this is Mr. Beckstrom, and today we're going to take a look at section 2.5. This is graphing techniques and transformations. And basically what we're going to be doing is we're going to learn how to, again, identify graphs based off of certain visual characteristics, and then use principles of transformations in order to find the equation that satisfies the curve shown. So let's go ahead and jump right into it. All right. So first of all, we have a function that looks like this. And we say, what type of function is this? Well, first of all, I could probably narrow this down to some type of odd function. And why? Well, because it looks like it is reflected across the origin. Basically, this point here, if you go to the origin and then you come across, so this is 1, 1, we have a point at -1, -1. At 8, 2 here, we have another point at -8, -2. So that's a great kind of first indicator that I'm dealing with an odd function. So we should be thinking about either odd degreed polynomials or maybe odd degreed radicals, such as like cube roots. So let's take a look at one. So for example, if the x value here is 1, then the y value is also 1. Well, that could be true for either type, because if you had an, let's say, an x cubed function, 1 cubed would be 1, and -1 cubed would also be -1. So we're going to need some more points in order to kind of get a better sense of what this is. Now I have 8, 2. So what can we do with 8 to turn it into a 2? And if you thought to yourself, oh, I can take the cube root of 8, and that's going to give me 2, then that's correct, because 2 times 2 times 2 is equal to 8. And the same thing over here, we have -8, -2. So the cube root of -8, that means what times itself 3 times gives us -8. Well, that is also -2. So looking at this function, I think the best guess is it would be a cube root function. The cubic function, the like x to the cubed function, would be a little bit different. It would be kind of going up, so it'd be concave up on the right and concave up on the left, being much closer to the y-axis than the x-axis as we're getting farther and farther away from the origin. All right, so again, notice the x values are the cube roots of the y values, and we can come up with a function that looks like it fits this extremely well, and that would be the cube root of x. All right, so let's take a look at some quadratic transformations. So a quadratic function is a function, it's a polynomial, means we have those x terms, x raised to whole powers like x squared, x cubed, x to the fourth. Sometimes we have a constant at the end, but quadratic means that the highest power is going to be our squared term. And here we see that this quadratic happens to be in the vertex form. What does that mean? It means that if you get into this form here, where a is some value, and then x minus h, where h is going to be the x value of the vertex, plus k, where k is the y value of that vertex. So here we go. Like a horizontal translation, we can see that this parabola here is just your normal f of x is equal to x squared. And notice that since we have a minus in the formula, that it's going to go a different direction than we may intuitively think. Because of the minus in the formula, when we add something, it'll actually move it to the left in the negative direction. And we subtract something, it'll actually move it in the right direction. So whenever we have a formula like that and there's a minus in that formula, we usually move it in the opposite direction to what we would normally think is positive and negative. However, the y translation here is positive, so that'll go up if it's positive or down if it's negative. That will stay the same. So here's your horizontal translation. Here's your vertical translation. So a positive k, that's a positive constant at the end, will move it up, and a negative constant will move it down. If you change the sign of the a, that's the initial value being multiplied by your first term there, your x squared term, then it will flip it across the x-axis. It'll reflect it across the x-axis. And finally, if a is something different than 1, if it's less than 1, if it's between 0 and 1, it's going to compress it. It's going to make it wider. So you can see this is in red. And as we make a less than 1 approaching 0, the curve is going to get flatter and flatter, closer and closer to the x-axis, and vice versa. When we make a greater than 1, then it's going to be a vertical translation. I think this part right here is incorrect. So ignore this. That should be a 1, and that should be a 1 here. So a is greater than 1, and a is between 0 and 1. I will go ahead and get that corrected. All right. Here are some other graphs that I did in Desmos here, just kind of showing you what will happen. So here, if you just start off with the black curve, which is the y equals x squared, notice it goes through the origin. It goes up nicely on both sides. Here, I've changed my a value. I've made it higher than 1. Therefore, it's going to kind of stretch it in the upwards direction, making it closer to the y-axis. And then I also added 2, which will, hold on, I got to relook at that one. Oh, shoot. Oh, no, that's right. Notice if you distribute this 3 out, you'll get 3x squared, and then it'll be plus 6. And so this moves it up in 6 units in the positive direction. All right, so this one right here, we have y is equal to the square root of x. That's our original function. And if we add 1 to the x value, remember the formula has a minus there. So that means we shifted 1 in the left direction here. And then this one here is shifted 1 in the left direction, the green absolute value equation. And then we subtract 3, which shifts it down 3 units. So it'll start here. And then you can also see what happens when we subtract a number from the x. It'll shift it right and then change it to a negative and make the a value between 0 and 1. It's going to compress it, meaning that it's going to move it closer to the x-axis there. All right. Let's keep going here. So why don't we try to sketch the following? So right now, I'd like you to pause the video. I would like you to start off with the function of just f of x is equal to x cubed. Go ahead and graph that. We can actually do that part together. So let's go to y equals, and then we're just going to do x cubed, enter. We'll start with a normal graph, so zoom 6. And this is what x cubed looks like. So I would like you to start with that. Go ahead and graph it. Graph a couple of points on it. Maybe use a table to graph x equals maybe 0, 1, 2, and -1 and -2 to get your y values. And then I want you to apply those transformations and see if you get the same kind of graph that we got earlier. All right. Let's go ahead and go through the solution here. So we have our graph. Notice that we showed it kind of went through the origin here. And what is this going to do? Well, the subtracting 4 from the x is actually going to move it right 4 units. So 1, 2, 3, 4. So the part that normally goes through the origin is now going through the x value at 4. And then we add 5 to it, which is going to move that up 1, 2, 3, 4, 5. So this is now the point that used to be, that used to be at the origin, and now it is starting at the 0.45. All right, hopefully we got that, and we can move on. Okay, I want you to try to write an equation that represents this graph right here. So again, I'd like you to pause the video and give it a try. All right, so coming to this now, this definitely looks like an absolute value function. So I would start with f of x is equal to the absolute value of x. And then it looks like the starting point here is moved 1, 2, 3 units to the right. So that means I'm going to subtract 3 from my x value, and it's moved 4 units down. So then I'm going to put a -4 at the end of the equation. And it should look just like this, just like that. Hopefully we got that. If you didn't, let me know, and we'll go through some other examples on that as well. All right, and let's try this one here. So again, I'd like you to pause the video, give it a try, and then we'll go through the solution. Okay, so as we saw earlier in the slides, this definitely looks like a odd root function. And in fact, it looks very much like the cube root function. So let's go ahead and apply the transformations to our f of x is equal to the cube root of x, and then we'll check to make sure that the points are lining up correctly. So if this is a cube root of x function, this is normally the point where it goes through the origin, but this is shifted 2 to the left and 5 down. Remember, shifting to the left adds the value, so that would make it the cube root of x plus 2. That would shift it to the left 2 units. And then outside of the cube root, we would do -5, and that should bring it down there. So let's give it a try here. So the cube root of, again, x plus 2, and then outside of that cube root, -5. And let's check a couple of different values here that we see on there. So it looks like it goes through this, this point here, and that would be 6, -3. So if I put in a 6 for my x value, that's going to be 6 plus 2, which is 8. The cube root of 8 is 2, and 2 minus 5 is, in fact, -3. So it looks like just finding a point on there kind of gives me a little bit more confidence that this is the correct function to use for this translation. All right. Write the equation. Y is equal to x squared with the following shifts in the order listed below. So first we want to move this 3 units to the left. 3 units to the left. Then we want to do 5 units up. And then we want to reflect it across the x-axis. So I would like you to try that first, to write a function. This is a quadratic with starting with y equals x squared, applying these 3 translations in the following order. So pause the video now, give it a try. All right, so let's see. So 3 units, so this is starting with just f of x is equal to x squared. I'm in Desmos for this. First, we shifted 3 units to the left, which means we add 3 to the x. And then we're going to add 5 units to the y. We are going to 5 units up, so that's going to be a +5. And then finally, we are going to apply a negative to the front of this, a negative here. And we should get a function that looks like this one right down there. Although, yep. All right. And that is all I have for this one. If you have any questions, please let me know. And I hope you have a great rest of your day. Please look out for the next video, which will be on another section that we're covering today. Thank you.